All right, today what we're going to talk about is probability with OR, the addition rule. And when we're doing this, there's some important things that you need to know. One of the things that you need to know is a mutually exclusive event or a disjoint. So it's basically two events that cannot occur at the same time. So if you have two mutually exclusive events, you can do the probability of A or B. And then when you get that, you can set it up as a probability of A plus the probability of B. You may also see it written like this, the probability of the union of A or B. So this is the similar to OR. So you just add your probabilities together. Another thing you're going to see is mutually inclusive events. So just like how you include something, it's two events that can occur at the same time. So it can be both at the same time. So if you were to have mutually inclusive, the formula would be, if it's A or B, you would take the probability of A, you add it to the probability of B. So far, it's just like what we had with exclusive. However, since you have some that can be the same thing at the same time, you have to subtract this, so it's like you're not double counting it. So you need to subtract this part, so you take out the ones that are the repeats. So we're going to do that, or like I said, you can come here and you can have the union here, you do the same thing. But this would be the intersection, so it's where they overlap because they're the same. All right, so let's go ahead, let's look at some of these situations. First, if you two roll a 2 on a 6-sided die, and then you roll an odd. Well, 2 is not odd, so these are mutually exclusive, meaning they cannot happen at the same time. All right, and then for this next one, we have, let me get my highlighter here. All right, so here we go. We have a 4. So the first event is you roll a 4, and the second event is you roll an even. Well, 4 can be even because that can happen at the same time. So what you actually have is an inclusive event. All right. Now, if you're to have set A, which is 1, 2, and 5, and set B, which is 3, 4, and 6, well, they don't have any repeats, so there's none that's in both. If I would have had a 1 over here, then it would have been inclusive. But since I don't, it's exclusive. All right, I want you to try these two. Birthday falling on a Monday and birthday falling on the weekend, and getting A in the next test and passing the next test. All right, we got a bunch of pretty colors here for you. So what we're going to do is first we're going to practice with the mutually exclusive. So again, we've got the keyword of OR, and when you see the OR, you're going to add the probabilities. And remember, if they're exclusive, that's it. You just add them. All right, so in a group of 120 students, there's 30 freshmen, 42 sophomores, 37 juniors, and 11 seniors. So we want to find the probability that a student picked at random is either a junior or a freshman. So I wrote down here what you would see. It says the probability of a junior, and then since it says or, we're going to add the probability of a freshman. All right, so the probability of a junior is 37 out of 120. The probability of a freshman is 30 out of 120. And since we don't have any repeats, we add them together and we'll get 67 out of 120. So again, we don't have any that could be both at the same time, so we just add the two probabilities together. So when you see or, we're going to add. All right, now let's do a mutually inclusive example. So remember, we have our formula here, and remember, now we're going to subtract the ones that can be the intersection of it or they're both at the same time because you don't want to double count it. So here we go in a group of 101 students, 40 are juniors, 50 are female, 22 are female juniors, and find the probability that a student picked from this group of random is either a junior or a female. So we're going to take the probability of junior, which is 40 out of 101. We're going to add it to the probability of a female, which is 50 out of 101. Now, if you notice, we have some that are female juniors. So since this is the overlap, we already counted them, so we need to take out the other ones so we don't recount them again. So what you're going to do is subtract the juniors that are female, which is 22 out of 101. And then you're going to get your answer of 68 out of 101. So this would be your final answer. So remember, if there's something that can be the both at the same time, you need to subtract that from your other probabilities. All right. So what I want you to do is we're going to make sure you're writing if it's exclusive or inclusive for each one. And we're going to look at this first one. Angel has 6 nickels, 4 pennies, 3 dimes. She takes 1 coin from her pocket at random. What's the probability it's a penny or a nickel? So it can be either of them. So since it could be either of them, we're going to take the probability of a penny. And we're going to add that to the probability of the nickel. Now, you can't be a penny or a nickel at the same time, so this is exclusive. So probability of a penny, probability of a nickel, add them together, and you get 10 out of 13. All right, so now, marble selected. You got 5 blue, 2 red, 3 white. What is the probability is blue or a white marble? So remember, with or, you're going to add them together. So in this case, it can't be a blue and white marble together, so it is exclusive because they're separate events. So I've got 5/10 for blue. I've got 3/10 for white. I'm going to add them together, and I'm going to get 8/10, which is 4/5. All right, so now let's look at this one. So here we've got a card selected from 52 cards. The probability it is a red or a face card. So you can have red cards, you can have face cards, but you can also have red face or cards that are red and are a face card. So this would be like your, you could have a Jack of Hearts or a Queen of Diamond. So that would be those examples. Do you like my beautiful pictures? All right, and then you could have a King of Hearts also. Oh, I missed my opportunity for Queen of Hearts. Okay, so anyways, you could have diamonds or you could have hearts. There you go, that's a beautiful heart. All right, so you can have some that are both. And then you can also have the diamonds. So you got Jack of Diamond, a Queen Diamond, and a King Diamonds. So that's going to be our 6 right here. So 1, 2, 3, 4, 5, 6, which is what I did right there. All right, so we have probability of a red is 26 out of 52 because half the deck is red. The probability of a face card, well, we have 3 face cards in each suit, and so there would be 4 suits, so it's 12 out of 52, and we're going to subtract any repeats. So we said we have 6 repeats out of 52, and then once you do all that together, you're going to get 32 out of 52, which simplifies to 8/13. So this one is inclusive since you can have both at the same time. All right, so I want you to go ahead. I want you to try. I'll erase that. Oh, actually, let me move it so I can keep my beautiful pictures. So beautiful. There we go. All right, so what I want you to do is you're going to write inclusive or exclusive for this problem, and then go ahead and solve it. And you're going to do the same thing here. You're going to write inclusive or exclusive for all of these, and then go ahead and solve them. All right, I want to do this one here because this is another example. It says a die is rolled. What is the probability of rolling a 5 or a number greater than 3? So if you're to have your probability, so your set would be these 6 options, 1 through 6. So if I rolled a 5, I have a probability of 1 out of 6. If I were to roll a number greater than 3, that would be 4, 5, 6, which is 3, 6. But if you notice, I have one number that's both. So I need to subtract 1 out of 6 or 1/6, and then I'm going to get 3/6, which simplifies. Why did I write 3? Wow. Oh, where's my green? It's not showing up. There it goes. Wow, good morning. Okay, there you go. All right, so when you're doing that, just be careful because you're going to be checking your information. So go ahead. You're going to write either exclusive or inclusive for all the others. And just be careful on this one. I know it's been a minute, but your vowels are A, E, I, O, U. All right, so just as a refresher, and go ahead and you're going to complete these. So just remember, if it is exclusive and they use or, you're going to just add. If it's inclusive and they use or, you're going to add the first part, but you need to subtract out any that's both. Oops. All right, and that is probability with or, the addition rule.